Good morning everyone. Today in this video we are going to see in detail about theory of acid-base titrations. But before discussing on the theories of acid-base titrations, let us recall some basic definitions on the types of acids and bases. So there are two types of acids and bases. You have strong acid, strong base, and weak acid, weak base. So what do we mean by strong acid and weak acid? So strong acids and strong bases are completely ionized in solution. So say for example, if I take a strong acid like hydrochloric acid, it will exist as H plus and Cl minus ions always in solution. Similarly, a strong base like sodium hydroxide will remain as Na plus and OH minus ions in solution. This means to say that you will not have any HCl units or NaOH units in solution. But if you take a weak acid or a weak base, by definition, they are partially ionized in solution. So, a weak base like acetic acid will have acetate ions, H plus ions and acetic acid units in solution. Similarly, a weak base like ammonia will have ammonia units as well as ammonium ions in solution. So, with this basic definitions, we'll move on to what are all the different types of acid-base titrations possible. Since you have four types of acids and bases, you have four possible combinations possible. You can have a strong acid, strong base titration, a strong acid, weak base titration, a weak acid, strong base titration, and a weak acid, weak base titrations possible. So of these four possible combinations, a weak acid, weak base titration is not possible volumetrically, because when you have both the solutions partially ionized chemicals, then it is difficult to identify the endpoint of the or reach the equivalence point of the titration. So the basic rule of thumb to do volumetric estimations for acid-base titrations is one of the solution should be a strong acid or a strong base. So now we need to recall some basic differences between the equivalence point and the end point of a titration, so which is often confused. So the equivalence point is defined by the reaction stoichiometry, whereas the end point of the titration is defined by the choice of the indicator. So the equivalence point is a point at which the base added completely neutralizes the acid being titrated, whereas your end point is a point at which the color changes to mark the neutralization of an acid by a base being titrated. So with this definition, we will move on to understanding the theory using what is known as titration curve. For an acid-base titration, a titration curve is defined as a graph of pH plotted as a function of the volume of the titrant. The titrant can be an acid or a base being added. So how do I generate the titration curve? So to generate the titration curve, I need a pH meter and the two solutions used for titrations. So I insert the pH meter in the solution being titrated, and the pH is measured after adding calculated volume of the titrant to produce the titration curve. And from the titration curve, the equivalence point can be read off. So what is the use of this titration curve? From the equivalence point, we will be able to choose a suitable indicator for specific titrations, and from the equivalence point and the volume of the titrant, it is also possible to calculate the unknown quantities such as concentration of the titrant. To understand the titration curve, we will take the example of a strong acid, strong base titration. So here, a pH meter is inserted into a conical flask containing 60 ml of hydrochloric acid solution, and then after the addition of 5 ml of sodium hydroxide, 0.2 mole of sodium hydroxide, the pH is monitored and it is plotted to draw the titration curve. So as the base is added, strong base like sodium hydroxide is added, it consumes the H plus ions, so the pH rises gradually, and you can see that the OH minus ions abstract the H plus ions to form the water molecule in this molecular view. So once the equivalence point is reached, the pH reaches 7 for a strong acid, strong base titration. So, and then it reaches, it rises gradually beyond that point. This is the typical titration curve for a strong acid versus strong base titration. As you can see, the pH at the beginning of the titration is very low because it is a very strong acid. So it is completely dissociated into H plus and Cl minus ions. And as we have seen in the previous video, as sodium hydroxide is added, there is a gradual increase in the pH of the solution, and there is a sudden rise in pH near the equivalence point, and the pH at equivalence point, when there is complete neutralization of the acid by the base, the pH is 7, and beyond that there is a sudden rise, and then there is a gradual increase in the pH of the solution. So from this titration curve, we can make a note that the pH at the equivalence point is 7 for a strong acid, strong base titration. Now you may ask the question, what will be the titration? How does the titration curve look for a weak acid versus strong base titration? So here you go. This is the titration curve. So I have overlapped the titration curve for a strong acid, strong base with a weak acid, strong base 1. So the curve in black refers to the one which we have seen in the previous slide, which is a strong acid, strong base titration curve, and the one in blue color, the titration curve in blue color refers to the titration curve for a weak acid, strong base. So you can see clearly the differences between the two. The first being the initial pH for a strong acid, strong base is very low compared to weak acid. For the weak acid, the initial pH is higher. The second difference, the obvious difference is, in the case of strong acid, strong base titration, there is a gradual increase till you reach the equivalence point of the titration. Whereas, in the case of weak acid, strong base, there is a rapid increase in the pH, and there is and then it tends to gradual increase near the equivalence point. And the third most obvious difference between the strong acid, strong base and weak acid, strong base titration curves is the pH near the equivalence point for a strong acid, strong base titration was 7. Whereas for a weak acid, strong base titration, the pH is greater than 7. So these are the basic differences, and the titration curve for a particular titration for a specific combination is very unique. So thank you for your attention.